Let us look at one more small example on circles. The problem says in the given figure, O is the center of the circle and angle XYZ is 45 degrees. How much is angle A is the question. So if you are observing X, Y and Z are the points on the circle. O is the center of the circle and we have angle A here, right? So as per the information we have, XYZ is mentioned as 45 degrees, right? This is 45 degrees is the information. So if you are observing carefully, XZ is the arc of the circle, right? We know from our basics that angle made by an arc at the center is twice the angle made by it in the remaining portion of the circle. So if you are looking at XZ arc is making an angle of 45 degrees at Y. So obviously at the center it will be making double that one. So that means we can say it will be 90 degrees. And we know one more small point that angle around a point should be 360 degrees. Already at O we have angle exposed as 90 degrees. So obviously the reflexive angle will be having the balance portion. So it is occupying the balance 270 degrees. So what we can say is angle A must be equal to this whole part, which is nothing but 270 degrees. So answer should be A is equal to 270 degrees. Let us look at one more small example on circles. The problem is in this way. In the figure below, O is the center of the circle and angle ABC is 50 degrees. Find the respective measures of angle AOC and angle ADC is the question. So if you are looking at ABC is mentioned as 50 degrees. ABC, this is what is mentioned as 50 degrees. And O is the center of the circle we have. So again using the same logic as what we have applied in the earlier problem. AC is the arc we have. Angle made by an arc at the center is twice the angle made by it in the remaining portion. So in the remaining portion if it is making 50 degrees, obviously at O it should make double of that one. So it should be 100 degrees. So angle AOC is 100 degrees we can say. Apart from this one, the question is asking for how much is the measure of angle ADC also. So if you are observing carefully, AC is chord of the circle. So in that case we can say this is minor segment and this is major segment. And we know angles in the same segment, angles made by the same chord in the same segment are equal. Angles in the same segment are equal. So if you are looking at AC chord makes an angle of 50 degrees at B. So obviously the same AC chord is making one more angle here at D, that also should be in that case equal to this ABC. So in that case what we can say is using that angles in the same segment are equal. If ABC is 50 degrees, ADC should also be 50 degrees. So in that way we will be having the problems based on circles. Let us look at one more variety on circles. This is dealing with tangents. In the given figure, PT and PR are two tangents. O is the center of the circle and angle TSR is 120 degrees. How much is angle TPR is the question. So if you are observing, O is the center of the circle is the information and angle TSR is mentioned as 120 degrees. So in that case can we say as this is 120 degrees, using the same logic TR is the arc we have. So in that case angle made by an arc at the center is twice that angle made in the remaining portion. So as at S it is making 120 degrees, at O it should make double, that should be 240 degrees. But already we know angle around a point should be 360 degrees, as already this is 240 degrees. So the balance should be here, that is again 120 degrees we can say. So this is 120 we have and we are looking for angle TPR is how much, right? So if you are observing as P is an external point and PT is a tangent, and O is, if it is radius, OT is the radius of the circle. We know radius and tangent at the point of contact always they make an angle of 90 degrees, or in other words tangent and radius at the point of contact are perpendicular to each other. So in that case what we can say angle OTP should be equal to 90 degrees. In the same way if you are observing OR is radius, PR is the tangent of the circle. So in that case angle made by OR with PR at point of contact, again this also should be 90 degrees. So in the quadrilateral if you are looking at PTOR, quadrilateral PTOR if you are looking at, sum of the angles must be equal to 360 degrees in any quadrilateral. So in that case if you are looking at angle at angle at T if you are considering 190 degrees we have, and angle at R if you are considering that is also 90 degrees, and angle at O, if you are considering inside that quadrilateral, is 120 degrees. So what we are left out is angle TPR, right? Sum of these four should be equal to 360 degrees. So already if you are looking at sum of these three, we have it as 90 plus 90, 180, 180 plus 120, 300. So bringing that 300 to the other side, it will become minus 300. So in that case, can we say angle TPR is equal to 360 minus 300, nothing but 60 degrees. So angle made by the tangent at P with respect to the circle, the TPR will be equal to 60 degrees. So this is one small example on how we will be having problems on tangents combined with arcs in that way. Let us look at one more example on circles. The problem says find angle XZO from the given figure, given O is the center of the circle, and in the figure we have these two as angles mentioned here. This angle is mentioned as 20 degrees in the figure, and we have one more angle, this is mentioned as 40 degrees. Okay. This problem is appearing to be on the same lines as what we did earlier, but this is some completely different from that particular problem, because that was mainly discussing, mainly focusing on arcs we have, whereas now we are dealing with the problem with one more aspect. So as OXY is mentioned as 20 degrees angle, if we join O with Y, in that case can we say OXY is an isosceles triangle? Because OX is the radius of the circle, OY is also radius of the circle. Obviously radius per any given circle is always same. So in that case what we can say is this side and this side are equal. So in that case, as two sides are equal, it will be an isosceles triangle, we can say. And in an isosceles triangle, angles opposite to equal sides are equal. So OX and OY are equal sides. So obviously we have OXY and OYX as equal angles. So in that case what we can say, this should be 20 degrees, right? And if we have that as 20 degrees, and if you are looking at OZY is mentioned as 40 degrees, using the same logic there also, OZ is the radius of the circle, OY is radius of the circle. So in that case OZY is also isosceles triangle with OZ and OY as equal sides. So obviously angles opposite to Z and Y should be equal. So in that case this also should be 40 degrees, we can say, right? So in that case can we say angle XYZ is 60 degree, totally 60 degrees or not, 20 plus 40, and now we will be using that angle made by arc at the center is twice the angle made in the remaining portion. If this is 60 degrees, obviously at O that angle made by this arc XZ will be double, so that will become 120 degrees, we can say. 60 is here, so at O center it should be double, so 120 degrees we have. So in that case, as the question is interested in finding how much is XZO we are interested. Again the same logic, OX and OZ are the radius of the circle. So in that case OXZ and OZX must be equal angles. So in that case can we say out of 180 degrees, already 120 degrees is present at O. So the balance 60 degrees should be equally divided between Z and X. So in that case what we can say is this is 30 degrees, even this also should be 30 degrees. So XZO will become 30 degrees. So this is the problem based on dealing with isosceles triangles in a circle. Let us look at one more small example of on circles. Let us look at one more small example, and this problem is dealing with angle in a semicircle. Yeah, the point here, if you are looking at the question, in the figure drawn below, AB represents the diameter of the circle. How much is the measure of angle BXQ he is asking for? And we have the information from the figure that angle XAQ is 30 degrees we have, and XQB if you are looking at is 40 degrees is the information. And as AB is the diameter of the circle, we can say this is angle made by that AB angle made by that diameter in the semicircle AQB, we can say. And we have a small theorem saying that angle in a semicircle is always 90 degrees, whether it is joining in this way or joining in this way, angle in the semicircle will be always 90 degrees. So in that case, as AQB should be equal to 90 degrees, out of that 90 degrees already at Q, that XQB, we have it as 40 degrees. So what we can say is AQP should be equal to the balance, that is 50 degrees we can say. And if you are observing, we are interested in how much is BXQ is the question, right or not? And if you are observing carefully, AXQ is a triangle, and for the triangle, this is what is the extended side we have. So in that case, can we say BXQ is basically the exterior angle of this triangle or not? And we know exterior angle at any vertex is equal to sum of opposite interior angles. So for AX cube, that particular angle at X, what are the interior angles that we have means A and B. So angle at A is 30 degrees and angle at Q is 50 degrees we have. So in that case, what we can say is angle BXQ should be equal to sum of these two, that is 30 degrees plus 50 degrees. So in that case, can we say it's 30 plus 50, 80 degrees. The question is asking for how much is angle BXQ, so it should be equal to 80 degrees. So in that way, we have looked at different varieties of problems on circles, starting with chords, then arcs, tangents and semicircle. We've even focused on alternate segment theorem in that way.